Hello everyone, welcome to AIT Tech Talk. My name is Narala Siddhartha. My roll number is 20951A6744. My branch is Computer Science Engineering with Data Science as specialization. So today my subject is Software Engineering. I am going to discuss about the industry academia collaboration in software engineering. So let us start. Okay. Tables of content. So I mainly divided the content into four parts. In the first part, I'm going to give an introduction about our topic and explain the fundamentals and other concepts about our topic. And in the second part, I'm going to discuss about the model development method and other methods. In the third part, I'm going to discuss about the IoT economic models. And finally, in the fourth part, I'm going to discuss about the conclusions and what are the pros and cons about this particular concept. So let's start. Introduction. Research collaboration between industry and academia supports improvement and innovation in an industry and helps to ensure industrial relevance in academic research. However, many researchers and practitioners believe that the level of joint industry academia collaboration (IAC) in software engineering research is still relatively low compared to the amount of activity in each of the two communities. The goal of the empirical study reported in this paper is to characterize the state of IAC with respect to a set of challenges, patterns, and anti-patterns identified by a recent symmetric literature review study. To address the above goal, we gathered the opinions of the researchers and practitioners with respect to their experiences in IAC projects. Our data set includes 47 opinion data points related to the large set of projects concluded in 10 different countries. Okay, in the software engineering domain, academia and industry are the large communities. Unfortunately, the level of joint industry academia collaboration initiatives in SE is still low. It seems that a SE researcher or a practitioner prefers to interact with the fellows from his or her group only. There are many events organized by each of the each of the two communities, but we usually see only handful number of participants from the other community in such events. There has been relatively two sides to collaborate on joint research activities. However, as observed by Boss, building scalable and effective research collaborations between the industry and academia in software engineering is known to be the challenging task. Chimalakonda summarizes some of the challenges that both sides of the such collaborative projects face, observing that most practitioners have perception that researchers work on dated or futuristic theoretical challenges which are divorced from industrial practice, while researchers believe that practitioners are looking for quick fixes instead of using systematic methods. Similarly, it is observed that researchers are more interested in proposing new techniques and tools focusing on technical novelty, while practitioners would appreciate solutions that work in their context regardless of novelty. Specifically, analyzes the time horizon aspects of long-term industry academia projects, which are generally shorter in industry compared to the academic perspective, creating risks for friction and frustration on both sides of the collaboration. Discussing key challenges of the industry academia collaboration points out that timeless is very important for industry and less important for academia. She further stresses that research outputs need to be crafted in different ways to be relevant to different stakeholders. That researchers focuses on rigor while industry focuses on pragmatic approaches, and that academics tend to report research findings in formats not easily accessible to practitioner. I provides The sum provides more examples of gaps between research and practice collected from a survey. In an attempt to reduce such a state of practice, there have been numerous efforts to understand the collaboration challenges and ways to make collaboration projects more successful. For example, the impact project of ACM 6soft tried to measure the impact of software engineering research on practice over 6 years, pointing out that the transfer of ideas from academia to industry is challenging and can roughly take 15 to 20 years. At IACSC 2011, the participants of the panel acknowledged the industry academia collaboration gap in software engineering and tried to identify key challenges of bringing theory and practical close together. Some of the panelists suggested that to reduce the gap between industry and academia in software engineering, industry should communicate their real problems and should share their case studies, while researchers should improve usability of the tools and methods developed and consider how to improve value, especially earning. In this case, ICSC 2012 keynote called attention to the need for inductive research, which starts from specific observations in real settings, as well as more thorough understanding of practice, although with closer interactions with the practitioners in the definition of research problems. This idea has been further emphasized in by advocating the case for context-driven research strives for practicality and scalability, satisfying the constraints in the given context. In spite of all those efforts, 20 years later, there still exists significant challenges for SC researchers and practitioners standing in the way of establishing and successfully running collaborative projects. So, model development method. So the Setters collaboration model was developed throughout the project lifetime incrementally and collaboratively with all project partners. We aim to allow all project members to share the collaborative principles. To this end, we used the practitioner action research, which is a knowledge development methodology involving action and reflection. The goal was to provide for everyone to participate in data gathering and analysis. The qualitative case study method to collect data for the model development, which included participant observation, reflections, workshops, and focus group discussions. The main method used was participant observation. This is a method in which data is collected symmetrically and unobtrusively through social interaction between an observant and informants. The first author of this paper participated both as an observer and active researcher in the collaboration during all 8 years. Okay, also involved in the research exploration project, which allowed to collect insights on the process of the model development and improvement based on the partners' feedback and data collected in observations. The data for the model development was collected frequently and in a continuous manner in a number of occasions. Notes from the meetings and information discussions among the project participants were taken daily. So, conclusion. The Setters collaboration model, which answers the research question of what elements are needed for an industry-academia collaboration to support research, knowledge co-creation in software engineering. These elements are problem scoping, knowledge conception, KNT development, KNT transfer, and KNT exploitation, organizational adoption, and market research. In the experience, a collaboration model supporting research knowledge co-creation has the potential to overcome notable collaboration challenges such as the lack of relevance, interest, and commitment from the collaboration parties. Compared to other industry academia collaboration models proposed in software engineering, the CERTES model presents a practical collaboration framework that details different roles and responsibilities of the project participants, ways of promoting commitment, and participative knowledge generation among project participants, as well as some directions towards the commercialization of research results. Even if all model phases posed certain challenges for the model development, there was one part which was the most challenging, that was devising the metrics that can be used for the measuring the KNT exploitation impact. Thank you.